Hi, I'm Tim Gilbert. I'm your BUS320 instructor, and I want to talk to you about Chapter 6, Section 3, Applications of the Normal Distribution. And what we do with this section is we learn how to convert from the physical world, from data that does not have a mean of 0 and a standard deviation of 1, which is the standard form. But we're going to be able to convert values from the physical world that are non-standard by using this little z equation, and that'll take us into the probability area. So let's take a look at what's the likelihood when we have some non-standard data. 172 pounds is the mean, 29 pounds is the standard deviation, and 174 pounds is the value we're looking for. What's the likelihood of getting someone who weighs less than 174 pounds? I put it into my conversion formula: 174 minus 172 over 29, and then I'm going to get a value that'll give me a z-score, and that will be related to some likelihood of those values happening at that score or less. I got a z-score of 0.07 when I put it into my conversion formula. The likelihood of that value occurring, 174 pounds, is 0.5279. So 52.79% of the time, a sample of one person selected from that population will weigh less than 174 pounds. I found that likelihood by going back to, once I had my z-score of 0.07, going back to table A-2, looking at 0.0, and then looking for the 0.7, the hundredths. There it is, 0.5279. Key concept: once you calculate the probability of a value being less than 174 pounds, once you calculate that z-score, the likelihood of z being less than 0.07, which we looked up in the table, was 0.5279, the likelihood of that physical world value that you tested matches this z-score. So this physical world value now has the same probability of occurring as that z-score had a probability of occurring. And that's the benefit of converting physical world measurements into standard form by using that z-score. Really important concept to get comfortable with. Some cautions to keep in mind: z-scores are not areas under the curve. Z-scores are tied to areas under the curve. And choose the right side of the graph or the left side. 0.07, slightly positive. We're going to use the right side. And if you had a negative value, you have to use the left side of the graph, and that would be table A-2 also, but it would be the negative values for table A-2. So let's take a look at another application, and that's using a little different form of the formula, 6-2, and that does just has been manipulated algebraically. X equals mu plus z times sigma. So let's see what that means in the physical sense. Just to show you where that equation came from, our original equation 6-2 was z equals x minus mu over sigma. I multiplied each side of the equation by sigma, canceling out sigma on this side, and now we have z times sigma. Then I added mu to each side, and that when we added mu on this side, this mu dropped out, and now we have mu plus z times sigma, and that's just flip that equation a little bit. X equals mu plus z times sigma. So let's see what that would have meant had we not known our answer was 174, but we were looking for the lightest 52.79% of the population. What value x would give us that? So now I used mu, 172 plus 0.07 times 29, which was our standard deviation. 172 plus 2, 174. So I could go at that two ways. I can use, depending on the information I have, I can use the value of 174 in our standard equation, or I can use this equation to find the value of 174 related to a specific z-score. And that z-score, the reason I use that, it's because it's tied to 52.79. So that tells me that if I have a value of 174, 52.79% of the population will be less than that. Let's take a look at another application. And I come to you and I say, okay, I want to know what's the weight of the person that'll be have 95% of the population weighing less than that person. What's that weight going to be? So I want to find the area under the curve here. I want to find the x value that will give me 95% of the passengers or 95% of the people being lighter than that. So I go into my table and I look for 95%, and that is a z-score of z equal 1.645. So 95%, remember, lied right between these two numbers, 94.95 and 95.05, but the z value, 1.645, is what I'm interested in, because I can put that into my equation and say, okay, if I have a mean of 172 and a standard deviation of 29, I'll multiply it by that z value, which is tied to the 95% probability, and I get 172 plus 47.705, 172 plus 48. So the value of x being 220 will give me 95% likelihood. So it's 90.95 or 95% likely that passengers will weigh less than 220 pounds. So I can come at this two ways. I can come at it with knowing what x is that I want to test against the mean and a certain standard deviation, and I use my regular conversion formula, or knowing the probability that I'd like to find what x value is related to that probability, and then I use this equation that we've just gone over. So the weight of 220 pounds separates the lightest 95% from the heaviest 5%. So we've talked about the non-standard normal distribution, how to convert it, and procedures for finding values using that equation. So enjoy your statistics, and I'll talk to you again on some other topics.